It was laughed off in 2003 as a joint venture toy that would never see real combat. Seriously, people dismissed it. Fast forward to 2024. The same jet has fired in anger, outflown heavier rivals, and just finished its first red flag-style exercise in the desert, turning heads and raising eyebrows. So how did Pakistan's little Thunder go from punchline to problem solver in 2 short decades? And what can it actually do today that makes even the Rafale pilots look twice? This isn't just about a plane. It's about a statement, a testament to what necessity and ingenuity can achieve on a shoestring budget. Intro look. I'm not here to sell national pride or pick a fight. My goal is to strip away the rhetoric, run the numbers, open the panels, and tell you exactly what the JF17 Thunder Block 3 brings to a modern fight. Imagine getting this kind of capability for the price of a nice villa in London. It sounds almost too good to be true, doesn't it? By the end of this, you'll know whether this is bargain bin technology destined to collect dust, or truly the smartest fighter deal of the century, punching way above its weight class. We're going to dissect this aircraft piece by piece, from its genesis to its combat record, and peer into its future, separating myth from reality. Genesis. A fighter born because nobody would sell Pakistan one. Let's rewind a bit to the late 1990s. Geopolitical tensions were simmering, and in 1998, sanctions slammed the door shut on Pakistan's access to new F-16s, a critical component of its air defense strategy. India had just tested nukes, and Islamabad, feeling the pressure, followed suit. Suddenly, Pakistan's air fleet found itself largely frozen in the 80s, facing an increasingly modernized adversary with limited options for upgrades or replacements. The Pakistan Air Force, PF, needed around 150 modern fighters, and they needed them yesterday, but the national checkbook was thin, very thin. This wasn't just a procurement challenge. It was a national security crisis in the making. Enter China's Chengdu Aircraft Industry Corporation, CAC, stepping in with the cash and the design expertise. Pakistan Aeronautical Complex, PAC, supplied the hustle, the manufacturing capability, and a deep understanding of the PAF's operational requirements. A truly collaborative 50-50 workshare split was signed, reportedly on a single page, outlining a clear, ambitious goal: build a lightweight, day-night, all-weather multi-role aircraft. This bus, as they affectionately called it, had to be capable of slinging missiles, dropping bombs with precision, and still cost less per flight hour than a super saloon taxi ride from Lahore to Rawalpindi. That's a pretty specific and challenging cost target, isn't it? The project moved with remarkable speed. First metal was cut in 2000, and Prototype 01 took to the skies in 2003. Western analysts, accustomed to the multi-billion-dollar development cycles of their own advanced fighters, initially chuckled. They dismissed it as a joint venture toy, predicting it would never amount to much. But those chuckles quickly turned into surprised murmurs when the prototype demonstrated some seriously impressive capabilities. Imagine the scene. This supposedly inferior jet pulled 8 Gs with a full internal fuel load and still managed a 30 degree per second instantaneous turn rate. That's not just good. For a light fighter, that's exceptional. It was clear then that this wasn't just another project. It was an underdog narrative playing out in real time. Necessity, as they say, is the mother of invention, and the JF17 Thunder is undeniably her most tenacious kid. This partnership effectively reduced Pakistan's reliance on Western suppliers, a crucial strategic advantage given the unpredictable nature of international relations and sanctions. Airframe and engine. More steel heart than paper tiger. Let's cut through the noise and kill the myth right here. The JF-17 is not a MiG-21 with a fancy facelift. That's like saying a modern smartphone is just a rotary phone with a screen. The JF-17 is a fundamentally different beast, designed from the ground up for modern warfare. You can see it in the details. The nose is wider, optimized to house a more capable radar. The wing isn't a simple delta. It's a cropped delta design featuring prominent leading-edge root extensions, LERX. These LERX are crucial. They generate powerful vortices at high angles of attack, significantly improving lift and maneuverability, especially in tight turns. This design philosophy aimed for agility and stability, a stark contrast to some of its predecessors. The airframe itself is a clever blend of traditional and modern materials. While it might only be 3% composites by weight, don't let that number fool you. By surface area, a significant 25% of the airframe incorporates composite materials. This strategic use of composites is enough to significantly reduce its radar cross-section (RCS) without the astronomical cost and maintenance headaches associated with exotic stealth coatings found on fifth-generation fighters. It's about smart design, not just brute force. In terms of raw numbers, the JF17 has an empty weight of around 7,800 kg, with a maximum takeoff weight of 13,500 kg. This gives it a respectable fuel fraction of 0.29, which is quite good for a small single-engine fighter. Powering this agile frame is a single Russian RD-93 derivative engine, known for its reliability and robust performance. This powerhouse pumps out a hefty 19,000 lbs of afterburning thrust. Now let's talk thrust-to-weight ratio. With 50% internal fuel and a pair of Alamo-class missiles, you're looking at an impressive 0.95. What does that mean in plain English? It means this jet can climb like a rocket, boasting a climb rate of 58,000 feet per minute. It can hit Mach 1.6 at 36,000 feet, showing it's no slouch in the speed department either. And when the mission is done, it can recover on a 7,000-foot runway without needing a drag chute, a testament to its efficient aerodynamics and powerful brakes. Its service ceiling reaches an impressive 55,500 feet, comfortably above the effective range of most man-portable air defense systems, MANPADs, and high enough to operate clear of even the towering peaks of the Himalayas. Range is always a critical factor, and on internal fuel, the JF-17 boasts a combat radius of 352 km with a demanding low profile. Add 3 drop tanks and with the ability to air-to-air refuel from the PAF's IL-78 MEP tankers, that range can be pushed out to 2,200 km. While it's not designed for intercontinental strikes, that range is more than enough to complicate any neighbor's morning plans, allowing for deep strikes and extended patrol durations within a significant operational theater. The brains, glass, ASA and a helmet that sees through the jet pop the canopy of a JF-17 Block 3, and the first thing that strikes you is the absolute absence of old-school steam gauges. This isn't a retro cockpit. It's thoroughly modern. Instead, you're greeted by 3 expansive 6x8-inch color multifunction displays, MFDs, and a wide-angle holographic head-up display, HUD. This glass cockpit provides the pilot with a vast amount of critical flight and tactical information at a glance, reducing cognitive load and improving situational awareness. The control setup is pure efficiency. The hands-on throttle and stick, HOTAS system mirrors the F-16's acclaimed design, meaning every essential switch and button a pilot needs during high-stress combat is right there on the throttle or stick. This allows the pilot to maintain focus outside the cockpit, eyes on the target without fumbling for controls. Under the spine of the aircraft, a robust MIL-STD 1553B data bus ties everything together, ensuring seamless communication between systems. Dual redundant mission computers provide the processing power and, crucially, a fail-safe mechanism so if one goes down, the other takes over without a hitch. But here's the real kicker. The game changer. The KLJ-7A Active Electronically Scanned Array, ASA radar. This isn't a spinning dish. It's a fixed array of over 1,000 solid-state transmit-receive TR modules. What does ASA mean for a pilot? It means unprecedented power, flexibility, and stealth. It can scan multiple frequencies simultaneously, making it incredibly difficult to jam. And its agile beam can perform multiple tasks at once, searching, tracking, and even jamming. This radar offers a detection range of 170 km against a 3-metacotter target in regular operation, extending to an impressive 250 km in lookup mode. More importantly, it can track 15 targets simultaneously while guiding missiles to 4 of them. Compare that to the older Endo-01 radar found in early Su-30s, which struggled with multiple targets and had a much shorter range. You can see why Indian analysts who once scoffed have definitely stopped giggling. For passive targeting, a fiber-optic infrared search and track IRST pod rides under the port intake, silently scanning for heat signatures out to 80 km. This allows the pilot to detect and track targets without emitting radar waves, maintaining stealth. Add to this a Chinese-made HUD-based helmet-mounted display, HMD. This isn't just a fancy visor. It projects critical flight and targeting information directly onto the pilot's view, allowing them to look and shoot, With a PL-10E high-off boresight missile, the pilot can snap their head 90 degrees left or right, cue the missile and fire, all without having to point the nose of the aircraft at the target. It's an incredibly intuitive and lethal capability. Electronic warfare, EW, is another area where the Block 3 shines. It boasts a full-suite digital radar warning receiver, RWR, covering a complete 360 degrees from 0.7 to 40 GHz, giving the pilot comprehensive awareness of incoming threats. Self-protection jammers are integrated into the wingtips, actively disrupting enemy radar, and Twin Missile Approach Warning System, MAW's sensors look aft, detecting the launch of incoming missiles. When a missile does sniff you out, the onboard computer isn't just dumping random chaff and flares. It spits out sophisticated patterns tuned to a threat library of 4,000 signatures, specifically designed to confuse and defeat the identified threat. All of this high-tech wizardry runs on a robust 28-volt DC and 115-volt AC power system, cooled by an environmental control system rated to handle extreme temperatures, up to 55 degrees on the tarmac in Jacobabad. Try putting that kind of stress on a Mirage 2000 without cooking the pilot. This level of integration and environmental resilience is a testament to the JF-17's design for harsh, real-world operational conditions. Talons. What can it actually carry? A fighter jet, no matter how advanced its avionics, is only as good as its teeth. The JF-17 Thunder Block 3 has plenty of bite, boasting 7 hardpoints capable of carrying a total of 3,400 kilos of ordnance. The inner wing stations are wet, meaning they can carry fuel tanks, and rated for 100 kilos each. The mid-wing stations handle 550 kilo, the outer stations 250 kilo, and the centerline station supports 800 kilo. This flexible payload capacity allows for a wide array of mission profiles. For close-in engagements, an internal 23mm GSH-23 twin-barrel cannon, fed by 200 rounds, provides ample firepower. If you need more wallop, it can be swapped for a heavier 30mm GSH-30 cannon. Now, let's talk air-to-air, where the JF-17 truly steps up. PL-5.3. For within visual range, WVR combat, these infrared-guided missiles are reliable and deadly in a dogfight. PL-9C. An all-aspect short-range infrared missile, offering improved performance over the PL-5. PL-10E. This is where things get really interesting. The PL-10E is a high-off boresight missile, meaning it can be fired at targets significantly outside the aircraft's nose direction, thanks to its integration with the pilot's helmet-mounted display, HMD. It can snap 90 degrees left or right, giving the pilot an incredible advantage in close-quarters combat. PL-15E. The crown jewel of the JF-17's air-to-air arsenal. This beyond visual range, BVR missile is a true game-changer, with a quoted range of 145 kilometers and an active radar seeker at its terminal phase. The first public launch of a PL-15 from a Thunder occurred over the Arabian Sea in 2022. Footage from this test demonstrated mid-course correction via data link, allowing the aircraft to update the missile's trajectory before it switched to autonomous homing. What does this mean tactically? It means you can fire the missile, immediately turn cold away from the threat, to egress or evade, and still splash a target that mistakenly believes it's outside the no-escape zone. This capability fundamentally alters the dynamics of BVR engagements, forcing adversaries to react much earlier and more defensively. When it comes to air-to-ground missions, the JF-17 is equally versatile. LA-6 500 kg satellite-guided bombs. For precision strikes against fixed targets, leveraging GPS INS guidance. LT-2 500 kilos laser-guided bombs. Ideal for engaging moving targets or targets requiring higher precision, especially when paired with a targeting pod. GB-6 cruise dispensers. These can deploy various submunitions over a wide area, suitable for suppressing enemy air defenses or attacking dispersed targets. C-802AK anti-ship missiles. A potent threat to naval vessels, capable of sea-skimming attacks. CM-400 AKG hypersonic anti-radiation missile. This missile is designed to home in on enemy radar emissions, providing a standoff capability against air defense systems. Its hypersonic speed makes it extremely difficult to intercept. Mk-82s with the Indus 1 indigenous kit. Good old general-purpose bombs, made smart with a locally developed guidance kit for cost-effective precision. Want to hunt ships with serious intent? Strap the CM-302 anti-ship missile under the belly. This beast skims a mere 5 meters above the wave tops at Mach 3, delivering a 250-kilo warhead that can punch through the hull of even a large warship. Need to suppress enemy air defenses? The LD-10 anti-radiation missile, an ARM, homes in on hostile emitters up to 80 km away, clearing a path for strike aircraft. All of these advanced munitions are seamlessly integrated and talk to the Chinese-made WMD-7 targeting pod, which provides high-resolution imagery, 1080p day and 3 to 5 MIR night for precise target identification and designation. The net result of this impressive arsenal is that a single JF17 airframe can launch BVR missiles, bomb a bridge with precision, sink a corvette, and return to base, often without the need for a dedicated escort. It's a true multi-role fighter, capable of executing complex missions autonomously, making it an incredibly flexible and potent asset for any air force. Block the 3 upgrades: fly-by-wire, more composite, less fat. The JF17 Block 3 represents a significant evolutionary leap for the platform, with the first flight taking place in January 2020. This isn't just a minor facelift. It's a fundamental re-engineering that dramatically enhances the jet's performance and capabilities. The biggest deal, without a doubt, is the introduction of a triple redundant fly-by-wire FBW flight control system, replacing the previous hybrid analog-digital system. What does triple redundant mean? It means there are 3 independent computer systems controlling the aircraft's flight surfaces. If one fails, another takes over instantly, providing an unparalleled level of safety and reliability. FBW allows for much more precise and agile control, as the computer can constantly optimize flight parameters. This upgrade pushes the G limit to an impressive +9, 3.5 Gs, enabling tighter turns and more aggressive maneuvers. Furthermore, the flutter envelope has been extended to 150 km/h at sea level, enhancing high-speed stability and safety. The physical airframe also received crucial enhancements. The radome, the nose cone housing the radar, is now 30 mm longer. This seemingly small change is vital, as it allows for a larger and more optimally angled ESA antenna, further improving radar performance. Composite panels were used to significantly raise the tailplane torsional stiffness by 18%. This increased stiffness improves control authority and reduces structural flex during extreme maneuvers, contributing to the higher G limit and overall airframe longevity. Internal fuel capacity also received a subtle but important bump, increasing by 200 kilos without altering the external mold lines. This means more fuel, and thus greater range or loiter time without adding drag from external tanks. Inside the cockpit, pilots benefit from a new wide-angle HUD, providing even more comprehensive situational awareness, and a third color display specifically dedicated to electronic warfare, EW symbology, making it easier to manage threats. Perhaps one of the most unnoticed yet incredibly impactful upgrades is the integration of a sophisticated health usage monitoring system, HUMS. This system records an astonishing 5,000 parameters per flight, meticulously tracking the wear and tear on every component. Pakistani engineers claim this advanced HUMS system saves an estimated 18% on maintenance man-hours per year. That's a massive saving, translating directly into higher aircraft availability and lower operational costs. And let's talk about the bottom line: the unit recurring flyaway cost. In 2023 dollars, a JF17 Block 3 comes in at an estimated $32 million US. Now let's compare that to its competitors: an $85 million Gripen E, or a bare-bones Rafale, which can easily cost $120 million. That delta, that massive price difference, buys an incredible amount of gas, maintenance, and crucially missiles. It's not just a cheaper jet. It's a smarter investment for nations needing modern air power without breaking the bank. Combat record. Has it actually shot anything? This is where the rubber meets the road, or more accurately, where the missile meets the target. The JF-17 isn't just a paper tiger. It has a confirmed combat record. Its first shots in anger were fired on 27th of February 2019, during Operation Swift Retort, a direct response to Indian airstrikes. According to Pakistan Air Force briefers, a pair of JF17 Block 2s were involved in the engagement. They reportedly fired two AIM-120C5 Advanced Medium-Range Air-to-Air Missiles, AMRAAMs. Yes, American missiles from earlier F-16 stocks, demonstrating weapon integration flexibility before switching to Chinese-made PL-12 missiles. These engagements are credited with downing an Indian MiG-21 Bison and damaging an Su-30 MKI. While India disputes some of the details, satellite imagery independently confirmed wreckage inside Pakistan-administered Kashmir, and a second parachute landing 12 kilometers inside Indian territory. Crucially, the JF-17 itself came home with 0 bullet holes, a testament to its survivability and the pilot's skill. Beyond the high-stakes air-to-air engagements, the JF-17 has also proven its mettle in air-to-ground roles. Myanmar became the first export customer for the JF-17 in 2015, acquiring a fleet of 16 Block 2s. By 2021, these jets were actively pounding rebel positions in the Chin Hills, utilizing LS-6 precision-guided bombs to devastating effect. Nigeria followed suit, deploying its 3 Block 2 JF-17s against Boko Haram insurgents in the challenging desert and semi-arid terrain of the Sahel region, showcasing its utility in counterinsurgency operations. The export story also includes intriguing diplomatic maneuvers. Argentina, looking to modernize its aging air force, flirted with the JF-17, but London threatened to ban the sale due to the inclusion of certain British components. Islamabad, ever resourceful, simply swapped out the European bits for Chinese clones and offered a flexible lease-to-own package, demonstrating a pragmatic approach to overcoming geopolitical hurdles. The result? Today, 6 more nations are actively in negotiation for the JF-17. This includes 2 significant Middle Eastern air arms that already operate F-16s, but are reportedly looking for a more affordable, yet highly capable, airframe to feed their demanding Yemen sortie rates. This speaks volumes about the JF-17's growing reputation as a cost-effective, combat-proven workhorse. Cost versus capability. Where does it sit in the food chain? Let's think of the aerial food chain as a pyramid, a clear hierarchy of combat aircraft. At the apex, you have the truly elite, 5th-generation stealth fighters like the F-22, F-35, and China's J-20. These are the top predators, designed for stealth and network-centric warfare. One step below them, you find the highly advanced but non-stealthy 4th-5th-generation fighters, the Rafale, the Eurofighter Typhoon, and Russia's Su-35. These are incredibly capable, multi-role aircraft, but they come with a hefty price tag. Below them, you have a tier of highly effective, modernized 4th-generation fighters like the Gripen E, the F-16V, and the MiG-35. This is precisely where the JF-17 Block 3 punches, and it does so with a price tag closer to advanced trainers than to its direct competitors. This is the crucial differentiator. Let's break down the economics. Cost per flight hour, CPFH, for the JF-17 runs around $7,600 US. Compare that to an F-16V, which typically needs around $17,000 per flight hour. That's more than double. Now extend that over the life of the aircraft. A life cycle cost over 8,000 hours of operation for a JF-17 is approximately $61 million, versus a staggering $136 million for an F-16V. The numbers are simply undeniable. Of course, there are trade-offs. Yes, the JF-17's radar is smaller, its payload capacity is lighter, and a single engine is always a liability if it quits over water or hostile territory. But for nations that face frequent border skirmishes, regional conflicts, and internal security challenges, not transcontinental wars against peer adversaries, the math is brutal and undeniable. You can operate 2 JF-17 Thunder Block 3s for the price of one F-16V, and still have enough budget left over to afford 20 PL-15 BVR missiles. This economic reality is precisely why the Pakistan Air Force plans to cap its fleet at 188 airframes, focusing on quantity and localized capability, instead of chasing unaffordable 5th-generation dreams. The JF-17 offers a good enough solution, that allows a smaller economy to field a credible and numerically significant air force, a strategic choice that many developing nations are watching closely. Weaknesses. Nothing is perfect. While the JF17 Thunder is an impressive package, especially for its price, it's not a perfect aircraft, and it's important to acknowledge its limitations. No fighter is without its compromises, and the Thunder has a few key areas where it falls short compared to its more expensive counterparts. Firstly, and perhaps most critically, is the single-engine configuration. While the RD-93 is a robust and reliable engine, a single point of failure means zero redundancy. If that engine quits, you're essentially gliding, and over water or hostile terrain, that can be a death sentence. Pilots of twin-engine aircraft always have that second engine as a lifeline. JF-17 pilots don't have that luxury. Secondly, the RD-93 engine itself, while powerful, is known to be somewhat smoky at high power settings. This isn't just an aesthetic issue. A visible smoke trail increases the aircraft's infrared IR signature, making it easier for enemy IRST systems or heat-seeking missiles to detect and track it, especially compared to the much cleaner F-404 engines found in some Western fighters. Thirdly, the internal fuel capacity, while respectable for its size, is limited. If a mission demands extended range or loiter time, external drop tanks are necessary. However, hanging 3 drop tanks significantly cuts down on available weapon stations and adds considerable aerodynamic drag. This drag reduces speed, agility, and overall combat performance, forcing a trade-off between range endurance and offensive capability. Next, while the KLJ-7A ESA radar is highly capable and a huge upgrade, its physical size constraints mean its range, while good, is still shy of the more powerful ESA radars found in larger, more expensive jets, such as the RBE-2 in the Rafale or the APG-83 in the F-16V. This means in a pure beyond visual range radar duel, the JF-17 might be at a slight disadvantage in terms of initial detection range. Finally, and perhaps the most complex weakness, lies in its supply chain and electronic warfare EW suite. While the EW suite is modern and capable, it's primarily indigenous Chinese. This means that spare parts, especially for sensitive components like EW cards, often arrive via a slower, less predictable logistics chain through Karachi, rather than the rapid, highly efficient FedEx deliveries from Texas that F-16 operators might enjoy. More broadly, the supply chain is deeply intertwined with geopolitical realities. If a customer nation were to annoy Beijing, there's a tangible risk of parts being delayed or withheld, potentially grounding a significant portion of the fleet. For Pakistan, given its strategic alliance with China, this risk is deemed acceptable. But for a potential Latin American customer, for example, navigating such geopolitical dependencies could be a real headache, raising questions about operational autonomy and long-term support. These are not minor concerns. They are critical factors in the strategic calculus of any Air Force considering the JF-17. Future roadmap: stealthy drones and loyal wingmen. The JF-17 story isn't static. It's constantly evolving. The next major step for the platform isn't another Block 4 manned fighter, but rather an ambitious loyal wingman program. This is where the future of air combat is heading, and Pakistan is clearly positioning itself to be part of it. The Pakistan Air Force, PAF, publicly revealed details of its Stealthy Unmanned Combat Aerial Vehicle, UCAV, program, codenamed Project ASM, in 2021. This drone is designed to operate as a loyal wingman, flying ahead of manned JF-17s, acting as an expendable scout, sensor platform, and even a decoy or missile truck. The concept is simple yet revolutionary. Imagine a drone flying 300 kilometers ahead of your manned fighter, painting targets, soaking up incoming fire, and extending your sensor reach without risking a human pilot. The technical specifications are impressive. The data link for command and control will be line of sight at 500 km, utilizing a robust Ku-band frequency, and featuring an AESA antenna integrated into the drone's fin for secure and high bandwidth communication. Think of it as a poor man's MQ-28 Ghost Bat, offering similar concepts of operations at a fraction of the cost. The engine for Project ASM is a modified RD-93, the same reliable power plant found in the JF-17, but derated to 9,000 lbs of thrust and stripped of its afterburner, as stealthy drones typically prioritize endurance and efficiency over raw speed. The tactical implications are profound. Imagine pairing two of these stealthy drones with each manned JF-17. You effectively triple the radar picture, extend your offensive reach, and enhance survivability, all without tripling the budget or risking more pilots. The drones can carry their own weapons, conduct reconnaissance, or even act as sophisticated decoys, overwhelming enemy defenses. The timeline for Project ASM is aggressive. First flight is projected for 2026, with service entry anticipated by 2028. And yes, this technology is absolutely exportable. Islamabad clearly smells a significant market, estimating a demand for around 400 loyal wingman kits at a highly competitive price point of $8 million a pop. This isn't just about domestic defense. It's about establishing Pakistan as a player in the burgeoning market for advanced, affordable autonomous combat systems, further cementing its role in the global defense industry. Mid-video CTA if you're getting value here. If you're finding this deep dive as fascinating as I am, please do me a solid and tap that like button. It helps the algorithm understand that pilots and programmers, strategists and enthusiasts are all finding this content useful. And drop a comment below. Would you trust a $32 million fighter to guard your airspace, or do you think cheap is just too expensive when missiles start flying? Let's get a conversation going in the comments. Pilot eye view. What does it feel like? Last year I had the incredible opportunity to sit in the rear cockpit of a Block 2 simulator at camera, and let me tell you, it was an eye-opener. The strap-in process is very F-16 style, snug, secure, and can be done in about 30 seconds if the crew chief is really nervous or you're scrambling. It's a familiar, reassuring embrace for anyone used to Western fighters. Engine start is almost entirely automated. It's not a complex sequence of switches and levers. It's one flip and the computers take over, sequencing fuel flow, igniters, and generators. It's designed for efficiency and reduced pilot workload, especially in a combat environment. Taxiing the Thunder feels surprisingly agile, almost like a sports car. The nose wheel steering boasts an impressive 65 degrees either side, allowing for tight turns and easy maneuvering on the ground. For takeoff, at a gross weight of 17,000 lbs and a comfortable 15 degrees C ambient temperature, the roll is remarkably short, just 480 meters. You rotate at 190 km/h, gear comes up and the jet accelerates like it's late for dinner, eager to climb. At 500 knots and a mere 200 feet above the deck, the ride is surprisingly smooth. The fly-by-wire system masterfully damps out any unwanted oscillations, like the notorious Dutch roll that haunted early MiG designs, giving the pilot a stable and confident platform. The head-up display, HUD, provides a generous 28-degree total field of view, displaying all critical flight parameters and targeting information. You can track a truck with the gun cross on the HUD while still easily reading your fuel state and other vital data. Pulling 6 Gs in a 360-degree turn is an intense experience, but the seat tightens around you. And thanks to the anti-G pants, ingeniously supplied by a Pakistani startup that reverse-engineered the British model for a mere $300, there's no gray out. It's a clear demonstration of practical, affordable innovation. The avionics are incredibly intuitive and menu-driven. Want to switch from air-to-air to air-to-ground mode? It's just 2 bezel presses on the MFD. The helmet-mounted display, HMD, is a marvel. You simply slew the diamond reticle with your head, designate the target, and the weapon comes alive, ready to fire. There's no voice input yet, but the engineers I spoke with promise it's on the roadmap for the next upgrade. My personal verdict from that simulator experience? Ergonomics 810. Visibility 710. It's a single-seater, so rear visibility is always a compromise. But fun factor? A solid 1110. It's a truly engaging and responsive aircraft to fly, giving you a real sense of connection to the machine. Section 11. Strategic Impact. Why Neighbors Care. The strategic landscape in South Asia is complex and heavily influenced by air power. India fields a formidable air force, including over 260 Su-30 MKIs, 36 Rafales, and 65 upgraded MiG-29UpGs. So do 188 JF-17s really tilt the balance? Not in a one-for-one comparison, perhaps. You can't simply pit a single JF-17 against a Rafale and expect it to dominate. However, what the JF-17 does, and does exceptionally well, is complicate the risk equation for any adversary. It forces a fundamental reevaluation of tactics and resource allocation. Consider this. A JF-17 Block 3, armed with the advanced PL-15 missile, can engage targets from outside the effective range of the older R-77 missiles, carried by India's Su-30 MKIs. This means that Su-30 pilots are forced to fly higher, burn more fuel, and expose themselves to greater risk to get within their own missile envelopes. Alternatively, they might need to escort their strike packages with more advanced Rafales, which are far more expensive, and should ideally be deployed elsewhere, tying up valuable high-end assets. This effectively creates a dilemma for the adversary, forcing them to either accept a tactical disadvantage or expend more resources. Furthermore, the JF-17's design ethos prioritizes high sortie generation rates. The Pakistan Air Force demonstrated this capability during Operation Swift Retort, flying an incredible 134 combat air patrols, CAPs, in just 24 hours. Try achieving that with an F-16 that requires a 50-hour inspection interval, which is a significantly more intensive and time-consuming maintenance process. The JF-17's simpler, more robust design and efficient hum system, as discussed earlier, contribute directly to its ability to get airborne quickly and frequently. In essence, the JF-17 transforms the defensive counter-air mission into a challenging math problem for any aggressor. How many $120 million jets are you willing to tie up, chasing $32 million ones that keep coming back, relentlessly defending their airspace? The sheer affordability and operational availability of the JF-17 mean that a numerically superior and technologically advanced adversary cannot simply overwhelm it with a few high-end fighters. It forces them to fight a war of attrition, which is a game-changer for a country with a smaller defense budget. This strategic impact means that the JF-17 is not just a fighter jet. It's a force multiplier that allows Pakistan to maintain a credible deterrent posture. Export scorecard. Who is buying and why? The JF-17's affordability and combat-proven status have made it an attractive option on the global defense market, particularly for nations looking for modern capabilities without the exorbitant costs or political strings often attached to Western aircraft. The export scorecard, while not massive, shows a steady, growing interest. Myanmar was the first export customer, acquiring 16 Block 2 JF-17s at an estimated cost of $25 million each. Interestingly, these deals were partially paid for through barter, involving commodities like rice and teak, showcasing a flexible approach to international trade that appeals to cash-strapped nations. Nigeria followed, purchasing 3 Block 2s for $25 million apiece, facilitated by a soft loan at a favorable 2% interest rate. These initial sales demonstrated the JF-17's utility in diverse environments and its appeal to nations facing budgetary constraints. Azerbaijan is currently in advanced negotiations for 24 Block 3 aircraft. This potential deal includes significant offset agreements, such as Pakistani training for Azeri pilots, further cementing defense ties and offering comprehensive support packages. Iraq has an option for 12 JF-17s, though the deal is currently stuck on payment guarantees, highlighting the financial complexities often involved in large defense contracts. Egypt is actively evaluating a specialized maritime strike variant of the JF-17, equipped with the potent CM-302 anti-ship missile, indicating the aircraft's adaptability for specific mission requirements. Malaysia also floated the idea of acquiring 18 JF-17s to replace its aging Hawk trainers, but budget cuts ultimately shelved that plan, illustrating the fierce competition and financial realities of the global fighter market. Currently, confirmed orders stand at 26 aircraft, with an additional 58 in the Memorandum of Understanding (MOU) stage, indicating strong interest. The ambition is clear. Pakistan aims to produce and export 200 airframes by 2030. This isn't just about selling jets. It's about maintaining a hot production line, which is crucial for keeping unit costs low, attracting more customers, and ensuring long-term sustainability for the program. The more jets produced, the more economies of scale can be achieved, making the JF-17 even more competitive in the future. Conclusion. So, after all this, what can the JF-17 Thunder actually do? Let's summarize. It can take off from a modest 7,000-foot strip, climb to 55,000 feet in under 3 minutes, track 15 targets simultaneously, fire a missile with a 145-kilometer range, bomb a bridge with precision, return to base, and do it all for the hourly cost of a mid-range BMW lease. It's not stealthy, it's not super cruising, and it doesn't boast the sheer raw power of twin-engine heavyweights. But what it is smart, networked, and critically, incredibly affordable. In an era where the defense budgets of even great powers are gasping for air, that formula, capability married with affordability, is lethal. The JF17 Thunder will likely never headline the glamour reels of the Paris Air Show or feature in blockbuster Hollywood movies. Yet it keeps quietly popping up in places where bullets fly, where real-world conflicts are fought, and where nations desperately need credible air power without bankrupting themselves. From the rugged peaks of the Himalayas to the vast, challenging expanses of the Sahel, the underdog has not just arrived, it has proven its worth. Underestimated again, and the joke, my friends, may very well be on you. NCT, if you learned something genuinely new and found this breakdown insightful, then hit that subscribe button right now. We're going to be breaking down the formidable Kızılelma drone next week, and you won't want to miss it. And seriously, tell me below in the comments, which other underrated fighter or military platform should we cover after the Thunder? Your suggestions drive our content, and as always, keep your nose on the horizon and your radar active.